Hi, I'd like to present this poster, Developing Hybrid Machine Learning Pipelines Using Cloud and HP Resources for the Permafrost Data Gateway. I'd like to start by mentioning Clouder, the software that we are using as a platform for this. It's an open source data management framework for long tail data. The name kind of comes because it's in the cloud and for data catalogs, and Clouder is a cluster of cats, so we felt that would be a good and memorable name. In terms of the basic architecture, Clouder's got a web interface, it's got an API, and it has an event bus that allows it to connect to extractors, which I'll explain later, and it does have different ways of storing files. There's also a lot of ability to make custom interfaces, which is why this is really useful as a thing for the Permafrost Data Gateway. Now, the thing about Clouder is that it's not a single service like Dropbox. Instances are always customized. You can also deploy in multiple backends like Docker or Kubernetes or AWS, just depending on whatever your organization is most comfortable with. What this kind of allows people to do is to upload, share, and index heterogeneous data and metadata. You can upload all different types of files. There's extractors that can extract metadata from many of these files. You have a way to search over the metadata, and you also have a way to generate visualizations and previews. Some of this is manual. You can manually add metadata, but probably the bulk of this is automatic. It's automatic in the sense that it runs whenever a file of a type is uploaded, and you always get the same things like metadata and previews. Extractors we've developed in Python and R, and really they can be done in any potential language. Here we can see the results of our GeoTIFF metadata preview extractor and the metadata it posts in a little bit more details. You can see it gets that it's raster, a polygon, it's got the coordinates, and it has a bounding box for it there. Here are two of our geospatial previewers. On the left, it's a GeoTIFF. This GeoTIFF is placed on a map where that image comes from. On the right, it's for a shapefile, and we have a layer that's over shown over a map. Now, within the context of the Permafrost Data Gateway, Clouder is this part in the middle. We get input data from a variety of different sources. A lot of this is coming from a lot of this is satellite data, so there's a lot of it. There are these various models that are trained, machine learning models that are trained on the data. And then what we kind of want to add are scripts that can kind of use these models to classify this data. And we want to have good previewers that can show a lot of information from this. We also want to develop, when it comes to that custom front end, that custom interface, we want to build a gateway that's a good front face that allows for the navigation and exploration of derived data products that's seamlessly and easily done for users. It's actually not very difficult to integrate existing scientific code into these pipelines. Basically, as I said before, you can pretty much adapt any code from any language. And the way we actually deploy these is we deploy these using a Docker image. And as you can see, these Docker images, I mean, once you have things written, it's a good way to handle all of your dependencies. And then that way you can install whatever you need. And you get basically, for whatever kind of code you're running, you can create the environment you need. We've currently focused on two different algorithms or scripts for our data pipelines. The first is the mapping application for Arctic permafrost and land environment Maple one. It detects ice wedge polygon and the permafrost region disturbances that classifies lake area change, fire scars, and retrogressive thump slaws from Landsat images pre-processed using the Google Earth engine. We can kind of see how this looks in Clouder. For the Maple one, we start with a GeoTIFF. You submit by looking at the list of the extractors and clicking on the one that for the Maple one, and then the output here is this shapefile, which we can see the layer where it's classified the ice wedge polygons on that map. Now, one of the issues here is that it requires GPU resources, which we don't actually have on our Clouder instance. So we use SSH to submit the job to exceed Bridges 2, which does have GPU resources. One of the things that we're going to do in the future is we do need to restrict access to this because HPC resources do have a cost, and we perhaps should supply quota. The other pipeline was for the permafrost region disturbances, and as you can see on the bottom, there's thaw slumps, fire scars, and lake changes. You can kind of see in these maps these things classified on a map. Currently, the pipeline starts with Google Earth Engine, then there's some process and model, there's some model training, and then there's the process area calculation, which happens entirely on our Clouder instance through an extractor. As you can see, it's a lot like the Maple code, where you start with some inputs. Here are these GeoTIFF images, you extract them, and then in the output you see these you see these images where pixels have been classified. Our goal, of course, in the end is to take all of the things that as this gateway, is to take all of these data products and eventually create like a very good visualization tool that would allow people to look at the end data. One of these tools is Fluid Earth Viewer. It's optimized for rapid loading and smooth interaction with global scale raster datasets, and also to be not particularly intensive in terms of the amount of bandwidth that it takes up. Another visualization tool is being worked on by the Arctic Data Center. This one uses cesium tiles, which allows for, when you zoom in, it allows for much greater detail than we do with the other. And as you can kind of see with the visualization workflow, it's like there's going to be kind of a lot more things that need to go in, but from taking the results of all of this code and eventually getting it done into these tiles. And so I'm going back to our central poster here. You can see that basically we can see the two different pipelines we've got, and we also can see examples of how this data in Clouder would be arranged in data sets and spaces, and just kind of a little bit of a summary of what we just went over. I added some extra slides in the presentation for greater clarity, and thank you for your time and attention.